Good, so this is about the DSC project blueprint, or how to start a DSC project the right way, because we have seen many DSC projects failing. And before getting into the details, who of you is using DSC for production? 4 or 5 people, maybe 6, okay, not many. Who has used it and failed or didn't like it and went another way? Okay, good. Yeah, the work that I'm going to present, and sorry, since the flight I have a little cough. I don't know, maybe the air wasn't dry. The work that I'm going to show is based on this gentleman's work here, Gail Colas. He has invented a lot of tooling around DSC, and since then we teamed up and developed it any further. And the paper that is summarizing all this, the release pipeline model, is a work from Steve Moraski and Michael Green. So that's the conceptual work, and we did the technical part in kind of turning it into something that actually works and that can be picked up. Good. That's the agenda. First of all, we are covering a little bit of the DSC basics, just to get into the terminology and how it works in the background. And then we are talking about configuration data, because that's the key. If you don't have a concept how you are creating your configuration data, then you're not getting much further. And so this is describing the change. And then the question is, how are we delivering the change? So how does whatever we want to happen on the machine actually gets there? It's being picked up by the machine and then also used to get into the desired state. That's the agenda. Overview. So the components of DSC, you might remember from previous workshops or experiences or papers. Everything is defined in a configuration. The configuration consists of a node block, and inside the node block you have your configuration items or your DSC resources. So I don't like the term DSC resource because you have DSC resources as modules, and you have DSC resources here as well, so I rather name them config items. But I think Gail said that DSC is pretty bad because there are so much terms that are not really well defined, right? Yeah. So that's a very simple DSC configuration. And by the way, if you have any questions, just ask them and we can handle them right away. Imperative versus declarative. We've heard that a number of times, and there's also a session about idempotency here. Pretty difficult word, and I've learned it when I first met DSC. And what we can see here is that the declarative array is much larger, or takes more characters, more lines than the imperative array, but only if you are doing your automation in a non-imperative way. Imagine that you want to write a script, and the script is implementing the idempotency by itself. Then, of course, this gets much longer, and it looks like this. So this is a script that is just creating a share, but checking if the share is already existing and doing all the logic internally, right? If you want to turn this into a DSC configuration, then I think the value of DSC is pretty obvious because it looks like this. Pretty structured, easy to read, and you don't even need to understand the PowerShell flow control in order to know what's happening here, because all the complexity is abstracted by the DSC platform, right? Good. Any questions so far? What DSC is, how it works? Then, we have 2 different modes in DSC. We have the push mode and the pull mode. The push mode means you are creating your artifact, or the MOF file, the instruction file, and you are sending it to the node by WinRM, by PowerShell remoting, and then the LCM picks it up and does whatever is necessary. And the pull mode means you are storing the files on a usually web server. I think this variant is no longer used. I've never seen it in the wild. So you put all your files on an IIS web server, and the nodes know about where to pull the files from and do this on a regular basis. So the default is every 30 minutes they look for a new configuration, but this is completely configurable, right? That's the difference between push and pull. Pull adds a lot of other values. For example, reporting. Because if a node picks up a configuration, it sends data back to the pull server, telling the pull server, okay, I had problems applying this and this resource because of whatever reason, right? So if you use DSC in a pull mode, then you have an overview about your infrastructure and you know exactly which machines are and which machines are not in the desired state. And if you are in push mode, this is a manual process, then you can use PowerShell scripts to reach out to the nodes and get the data from there. And of course, it depends on how many nodes you have. The customer with the most nodes that I'm dealing with has about 55,000 servers, worldwide distribution, and you need to have a central monitoring system or a central database that stores all the nodes configurations. Otherwise, it would be impossible to query 55,000 nodes on a daily basis. It simply takes too long. Yeah, that's the difference between push and pull. So in the enterprise, you usually use pull just for comfort and for reporting. Good. Configuration data. This is, I think, the hardest part of DSC. And before Gale came up with his data module, it was done wrong, I would say, all the time. I haven't seen any successful DSC implementations. I remember I was with a British bank one day, and they said every time they do something to their DSC configuration, they do a change in DSC, something goes completely wrong. Even sometimes they had outages. Right? And this is the opposite way of what it should be. Actually, this should add a lot of trust into our change process. And if at the end it does the opposite, then the whole idea wasn't working and the whole idea was wrong. Yeah. Unfortunately, Microsoft was very eager, or Microsoft consultants have been very eager to put DSC into the field before it was at a state that was ready for the enterprise. I remember that DSC 1 in PowerShell 4 was kind of a disaster, I would say. And every project that was based on DSC 1 was kind of a failure in the first place. Yeah. And with PowerShell 5 and DSC 2, everything got much more stable. Yeah, so configuration data. What is it? Configuration data is an automatic parameter that we can use to inject data into our configuration. And the data is made available as the configuration data variable. We will see in a minute what that means and how DSC is picking up this information. And it allows to provide data to the configuration, yeah, and is the key for separating the configuration and the configuration data. The configuration could be just install some Windows features, right? And you don't want to change the configuration just to be able to change the number of Windows features that you want to install. So what we have is a configuration that installs some Windows features, and the configuration data defines which ones we want to install. So this needs to be merged somehow, right? And actually, configuration data is just a hash table. And we all know hash tables in PowerShell. They're pretty flexible, fast, and this is what Gale picked up, because his module is at the end kind of creating a very large hash table. And this hash table is then used by DSC to do some magic. Yeah. The hash table needs to have a certain structure like this. You have the old nodes key. This is mandatory. The rest is pretty much up to you. You can do whatever you want. Good. So how does it look like in the wild? Configuration data demo, and I have two scripts here. For simplicity, I'm switching to the ISE, even if it is not state-of-the-art. And here we go. We have these two scripts. We have our configuration. Big enough? Good. The configuration, and this is a typical sample that you will find in a bunch of articles that are talking about the separation between configuration and configuration data. So the configuration is just installing on every node that is a web server some some website. Or first of all, it copies some data to the machine, then it creates a website, and then it installs whatever Windows features we find in the configuration data, right? So somewhere this needs to be defined. And for file servers, we are just creating a file, and that's it. And for all the machines, because here we have the section that is, I love this bug in the easy steroids. How can I collapse this one? I can't. Okay, so here we have the web server section. Down here we have the file server section, and this applies to all the machines for configuring network stuff, right? And by just looking at the file, you can easily see that this is not scaling very well, right? I mean, we are just configuring 3 settings in the network. We are creating a website, we are installing Windows features, and it's getting large already. So you can imagine if you want to install or configure a SQL server with 500, 600 settings, then this file gets unmanageable pretty quickly. Yeah. So let's compile this without configuration data first. And what's happening then is nothing. By the way, do you know the DSC compilation process, what that means? Does it ring a bell? DSC compilation MOV files? Okay, so DSC is, or to go one step back, the local configuration manager is a component that runs on every Windows computer. And the local configuration manager is picking up the DSC configuration and makes sure that we are getting into the desired state. The local configuration manager does not understand this. So the local configuration manager has no connection to PowerShell at all. So what we have to do is we have to convert this, when we speak of compilation here, we have to compile this into something that the LCM understands, and that's a MOV file, right? And the whole publishing process actually is just taking the MOV file and copying it to the System32 configuration folder. And then at some point in time, the LCM takes the file and does whatever is written into the file. So it takes the instructions and follows these instructions, right? So we need to convert this into a MOV file. And it doesn't work because I'm missing the resources. Okay, let me cheat a little bit here. DCD git DSC Workshop build task. By the way, this is sampler. This will be explained on Thursday morning. It's a module scaffolding project that does a lot of magic. So let's see if this works. It does. It has worked, and let's see, what kind of MOV files have we created? Nothing. So it's still empty because, you see, we are compiling MOV files for whatever is defined in all nodes.nodename. And this is coming from, or should have been come from, the configuration data, right? So in the configuration data, we have defined that we have two nodes, MS1, MS2. Both have different IP addresses, both have different roles, and then we have some information about what kind of website and, the web server role, what we want to do there, and what kind of baseline information we have, right? So this is pretty basic. It's not very, not very nice. If we would follow this, then definitely that's a failure. So let's implement the configuration data as well. And here we have these two MOV files. So if you want a machine to use the MOV file, it's either you push it using PowerShell, which is doing a start DSC configuration, or you take the MOV file and you copy it to the folder system32/configuration. So that's the very basic, right? But if we have to deal with all the basics, then DSC is not a very big help because, this is a pretty manual process. So we need some tooling around to make this much nicer and, more DevOps aware, because this is just, like it worked a couple of, or 10 years ago. Question. Yes, please.
The web server command on line 67, where is that defined?
67, you mean this one? Ah, good. So that's the configuration up here. So you can think of a configuration like a function. And in order for the function to do something, we need to call it. And in order for the configuration to get compiled into an instruction file, we need to call it as well, right? And the configuration has a bunch of default parameters that you can see here, right? And one of the default parameters is the output path. So where do you want me to store the MOV files? And the other one is where do I find my configuration data, which can be either a hash table or a file that contains a hash table. That's it. Other questions on this? Let's have a look into the MOV files. Okay, and actually this is pretty much the same that we have in our ISE. So here we have, for example, a resource that is copying data to a certain directory, and this is it. So it's kind of translated whatever we have done in PowerShell into a pretty hard to read format. So usually you don't have to deal with the MOV files at all. Only if you have a serious issue and you need to do some debugging. Usually it's just converting it into a MOV file and then forget it. And then later we'll see the release pipeline picks up the MOV files and copies them to the destination where they belong to. Okay, good. Then let's close that. Yeah, that is the configuration data, just a hash table that we inject into the function or configuration. This I have taken from a official Microsoft offering, which is called a SharePoint deployment accelerator or solution accelerator. I think it's not really an accelerator because you're ending up with configurations that are about 2,000 lines big. So this is just the configuration to deploy a SharePoint farm. And you can see managing this is pretty difficult, right? And pretty often you have something like this in here. They have also hard-coded paths in the configuration, which means they didn't follow the rule to separate the configuration from the configuration data, right? Can you imagine working with this kind of configuration files, 2,000 lines, and you have to do a change there? Yeah, this is pretty likely going the wrong way, right? And this is just the configuration. The configuration data is another file of 1,200 lines, right? And looks like this. Yeah. So, and when I've seen these kind of solutions the first time, I was pretty scared of touching DSC at all, and it took me a while to get to know it and to love it because, yeah, there was no tooling, and we have invented some tooling. Actually, we met in 2017. I was doing a DSC project for BMW. They wanted to automate their 300-something domain controllers, and we were allowed to present this on the PowerShell conference 2017. And then I met this gentleman who told me that our approach is quite nice, but it's lacking some fundamental principles and eventually will fail as well, even if it was much more mature than what we had in the wild. And yeah, and this is why I got introduced to some new concepts and new tooling, and this is then our next part. So this is just how DSC worked so far, how the platform is working, and now we get into the tooling and into how we can make this platform really a productive companion. Good. Describing the change. So now we need to solve the configuration data problem. So we need to find a way where we can kind of set up our configuration data in a way that other people can easily read it, maintain it, change it, maybe even do some reporting to get an idea how the final configuration of a computer at the end looks like, right? We don't want to deal with these 2,000 lines long files. We want to have something that is much more according to our normal thinking, to how we think about computers. And so the structure of configuration data must somehow reflect the real world. And if we think about the real world, we always think in layers, right? We have file servers. File servers, or all the file servers have something in common, hopefully. Otherwise, we have done something wrong in the first place. All file servers usually also get a kind of baseline. So we have a corporate baseline or maybe a regional baseline. Then we have maybe a location-specific setting. So we have a bunch of layers that we are merging in our brain to something how the computer looks like at the end. And when we think about layers, sometimes we want that the highest layer wins, that the highest layer overrides whatever has been defined down there, or we want to merge information. For example, let's say our baseline, our security baseline has defined that Telnet has to be removed on every computer. That's our baseline, right? But then we also define that other Windows features have to be added or removed on higher levels, right? So the baseline defines some Windows features to be removed. The file server, the role defines some Windows features to be added. Then we have maybe a certain location, which is using some kind of backup software, but that requires another Windows feature as well. And somehow this all needs to be merged into one big list of Windows features that is actually getting pushed to the node, right? So it's either overwriting or we need to merge data. This needs to be taken care of as well. And we can think of the layers like that. So we have our cattle, our pets. I think you heard it all in the talk from April about DevOps already, right? Sorry. And this was already mentioned. The baseline defines our basic settings. So here we have our cattle. And the more we go up, we are getting more node specific. And for example, the solution that we developed for BMW was capable of handling a baseline and a role. But it was so inflexible that we could only take care of 2 layers. We didn't even think about adding a 3rd layer because we didn't need it. And yeah, this was why Stephen Moraski told me you don't understand the solution to a problem because the solution that I'm going to show you is quite complex if you don't have the problem, right? And we didn't have the problem. We will run into this problem at some point in time, but we didn't have it at this day. So, and this solution is completely flexible. So we can have this kind of 5 layers here, baseline, role, environment, location, node, but you could also put another layer in here, for example, fire sections. If you have a data center and you want to separate between the 2 fire sections, or you have maybe another service layer that you put in. It's completely flexible and it's completely up to your organization to define how many layers you need and you want to have, right? And if we are looking for software packages, for example, so what software package do we want to install on a certain computer? Then the lookup, wait a minute, works like this, that we are looking for software packages at the baseline and, at the baseline first, then on the role level, environment level, so we're getting more specific. So at the end, we are merging the software packages from all layers and, install on the nodes whatever has been defined on all these layers that have been merged. That's the basic concept. Does it make sense? Does it raise questions? Good. Somehow my mouse wheel is pretty sensitive and I'm trying to, but it doesn't work. Yeah. Sorry if I'm jumping forth and back here. Okay, so, but if we have our configuration data in a nice shape, then the next question is how do we kind of connect the configuration data with the configurations? Remember, the configuration data is what DSC is actually doing. This is what is getting converted into a MOV file. The configuration data is just the part that is getting injected to the configuration during the compilation process, right? So somehow this needs to be mapped to the configurations. And I think, has anybody of you heard the term composite resources? Has anybody used them? No one, yeah. And I wouldn't have used them as well. So there are some composite resources for SQL Server that are quite nice because setting up a SQL Server does require much more than just the actual setup. Usually you copy an ISO file to the machine. You have to mount the ISO file. You have to do the initial setup. Then you have some configuration pieces afterwards, like whatever, I'm not a SQL expert, but if I look at the configurations, they usually consist of 30, 40, 50 different elements. So what we can do is we can take these 50 elements and wrap them in a composite resource. So you can think of a composite resource like a function around functions. And in the DSC term is a configuration around configurations, right? So instead of having to repeat myself all and all over again, we have just one block that we can put somewhere, and this block contains exactly the instructions that we need to get to a certain point, right? And this is what we are using here. So the configuration data that we look like in a minute is done in YAML files. And the DSC resource that is installed on our nodes is not understanding at all. It doesn't even understand the format, right? So YAML and DSC doesn't have any connection. So we need to kind of bring this into a state that the resource can understand. The problem is here, if we have Gail has, this is a slide from Gail, I stole it from him, and he is explaining it the other way around. I like it rather from the top. So let's start here. So we have a file server. The file server is connected to the file server role, right? We're thinking in layers. So the file server role defines that we want to create a couple of files and folders on a certain machine. The problem with that is that this resource here does not understand the data because it cannot handle an array of information. So this resource can only create one file or one folder. It's like a function that is accepting just a single name, right? So if you want to invoke this function as many times as defined in the configuration data, you have to create a for each loop, right? And this is what we actually do. So we have a composite resource. The composite resource gets the configuration data, and the composite resource calls the file resource as many times as it is necessary to do the job, right? So it's just another abstraction layer. This data isn't compatible with the resource, so we do something, or we put something in the middle that does the translation for us and does exactly what we want, right? We are not going into details about the composite resources, that's a bit too hard, but it's all on GitHub, and we have also a couple of exercises pre-created, and the exercises are guiding you through the whole material on your own pace, right? But that's the basic idea. Does it raise questions? So let's have a look at the data actually. And yeah, these are the connections, right? And yeah, I will explain in the live data. I think this is more interesting. So hierarchical data. VS Code. And so this is how it looks like. How about the font size? Is this okay? Good. So the folder that we are looking into is the source folder. The source folder contains my my configuration data, and it's like an infrastructure control repository. So all the other folders that you see here have nothing, or actually they're not required. The only folder that we require is the source folder and the build files down here to do something with the data. And if we want to, let's have a look in how the source looks like. Environment, then let's expand the roles, expand the baseline, let's expand that, okay. And let me get my zoom it. Good. So this is the definition of a file server. Don't get distracted by that strange syntax that has been recently added and is just variable interpolation. So whenever you see this strange syntax, it is just calling PowerShell, and PowerShell grabs data somewhere and puts it exactly into that key value pair as the value, of course. So we have a file server here with a certain name, the role is file server, description, and so on. And where is the relationship between the file server and whatever the file server role contains? It's just here, right? So we have the role, and the role points to, wait a minute, I need to go down here, and the role points to the file that we see here. Then we have an environment. The environment is taken from the base name of the file, which is actually, now it's gone. For example, wait, let me do this a bit differently so we have it clearer here. Let's take this node because it's further down the row and start from scratch. So we have our role. Role points to the file server role. Then we have our environment. The environment is the base name. Base name means the root folder or the parent folder of this file. And the environment then points to whatever is defined in here, right? So each of these key value pairs may point to another file if defined. Yeah, so it's not easy. So where is it defined? Why do we actually look up exactly what is defined here? Why are we looking up roles, locations, environment, and so on? Because we have one file, and this single file is describing the data. Maybe I should have shown this first. And this file is the datum YAML. And the datum YAML tells the whole discovery process where to look for data. So we are starting at the DSC LCM baseline, because every machine needs to have some kind of DSC pull configuration. So this is what every machine gets. Then each machine may have a different baseline, right? And the baseline is this one here. We have the DSC LCM baseline, security, and server. So whatever baseline is configured on the node, come on, here we go. Whatever baseline is configured will be taken from the baselines folder and then processed. And the baseline is just another YAML file that contains some instructions. Then we have hard-coded that the security baseline will be applied. Next layer is the role, right? So role is here, file server. So we go down to the role container and look for exactly that role. The locations, environment, and nodes. And this is also the solution why this is so flexible, because you can just remove or add layers here. If we don't need a security baseline, just remove it. And then it won't be considered any longer. If you need something extra, you can just add it. So this information, the resolution precedence, needs to just match your folder structure. That's it, right? And if you do something wrong, then yeah, you will pretty easily see that the output is not as expected. Right. And if we do a mistake here, well, let's try the compilation first to give you an idea how this looks like. Build. So we've said that we have multiple layers. And we have also said that this concept is much easier than what we have seen before when we are dealing with DSC. Is it? So if somebody asks you, what's the configuration of file server 2? Okay, then you click on file server 2 and you tell your colleague, yeah, that's the configuration. Okay, but this is a file server. How do I know from that file how the file server actually looks like? Because it implements, yeah, settings on the role layer, implements settings on the location, implements the baseline. So what's the full configuration? Okay, then let's have a look into the baseline. What does the baseline do? The baseline here is configuring some global IP settings. It is configuring Windows event logs, but that's still not the full view, right? You need to have a look into the role. You need to have a look into whatever layer this node will apply. And this is now solved, not now, it's solved since when? 19? Yeah, 19, 18, with RSOP. Everybody has heard the term RSOP in regards of group policy Active Directory, because we have the same problem with Active Directory. You have a computer that is in a certain OU, but by just looking at the OU, you have no clue about how many group policies we are applying, because this is inherited from the tree where we are, right? So getting the full information about how the configuration of the node actually looks like, is the RSOP process. And this is exactly the same here. So we go to our RSOP folder. Here we have one RSOP file after the build for every machine. And this is now the full view of it. And you see also these strange syntax, x equals script block, disappeared because it's now resolved. And you have the view that actually is configuring the machine. RSOP, right? So this is a fundamental improvement over the previous DSC, the DSC configurations or the DSC workflow that we had, because you never have an idea. Let me go back to this strange file here, right? So you have no idea how the server looks like at the end, because in the middle you have script blocks, you have some hard-coded values, you have some values that might come from other text files, so it's impossible to actually grasp how the machine looks like. And with this feature, it's much nicer. And if you want to know, so the next question was sometimes from customers, yeah, okay, I see there is a folder, but where is the folder defined? From which layer? Then we have RSOP files also with source information, and then it looks like this. Unfortunately, yeah. And here we have the information where the setting is actually coming from. Right? This helps you very much if something is not as expected, then you know exactly on which location you have to look for the error. Right? Good. So the data model is just a number of YAML files in a hierarchical order that this whole data module that is managing these files is putting into one big hash table. And just to give you an idea what's happening in the background, new datum structure and the hierarchy definition file. So that's the key file is .source datum YAML. Datum YAML. Oh, wrong file. Oh, wrong parameter. Definition file. Okay. And this is it. Right? So what it does is it just takes the file and folder structure and moves it into a hash table. And we will find the same path that we have in our source folder right here as well. So $D has an all nodes key. In the all nodes key we have the environments, which is def, and here we have the DSC file server 1, and that's the information. So that's the raw data, unmerged, and also these script blocks or these handlers have not been resolved yet, but it just gives you an idea that in the background we are just reading the files, converting it to hash tables, and then these hash tables are further processed. Right? And that's the magic actually, because previously you had just one hash table that you did more or less manually. There was no kind of layering because a hash table doesn't know about layers, so this had to be implemented somewhere. The merging process is done in the background, not here, but in the compilation process, so that we are merging all these elements to one RSOP table, and the RSOP table is then used for actually creating the MOV files. Good. Another nice thing is you only have to kick off one script. And this one script is creating all the resources for you to actually get going with DSC. Does anybody of you know how many files How many files are required if you want to use DSC in push mode? 1.5? Actually 1. You have the MOV file, you're pushing the MOV file to the other machine. Maybe a bit more than 1 because you need the resources on the other machine as well. So if you are configuring networking stuff, the networking resources are in a community resource called networking DSC. If you don't have that on the target machine, then your LCM, the DSC engine, has no idea what to do with the instructions because the middleware is missing, right? But actually, it's just 1 file, given that the resources are already there. In push mode, we need a bit more. In pull mode, sorry. In pull mode, we need the MOV file. We need a checksum file for the MOV file. We need a LCM configuration script, the metamov file. And we need the compressed modules, so all the resources, the DSC resources that we need to actually apply the configuration, plus the checksum. So we have 5 different artifacts, and these artifacts are just created using the single build script. So in the output path, we have our compressed modules. We have log files, metamov files. We have the MOV files separated in environments, and we have, what else? Yeah, the required, no, that's it. Yeah, and the RSOP files, but the RSOP files are not used for actual DSC. So everything is pre-created just by kicking off 1 script, and this is the I would say the requirement to kind of move this into a DevOps release pipeline, because if you need to create the artifacts manually and need to copy them around, then things don't work as expected. Good. Any questions on the configuration data? I know it's a tough call. It's a lot of content and it's pretty complex. But if you're interested in the solution, then you may want to go to the DSC Workshop. Where is it? Here. And here we have exercises. And these exercises can guide you through the basics of DSC. And if you know DSC already, then you can just jump into exercise 2. And exercise 2 guides you through the build process, guides you through how to add nodes to the configuration, how to change roles, how to implement new layers, so it's all in here. And I think is the most effective way to actually learn about the project. It's good.
You show the link.
You mean this one?
Yeah, we can't see it.
Actually, just this first part is important, and the rest is pretty easy to find. So let's go through actually a change process. Because what I have done is just navigating a little bit through the configuration data. And I have shown you that we have all the artifacts created through the build pipeline. So what happens if we want to add another node here? Let's say we want to have file server 10 in the dev environment. Then we just go into our source, dev, and we do a copy and paste on the file. Copy, paste. And is there anything that we have to change inside the file? Well, yeah, let's change the IP address to something that we don't want into a conflict, 199, perfect. And that's it. And then let's kick off the build script again. The name? Oh, yeah. Yeah. 10, like that. Good. And then our the pester tests will be explained a bit later because there is a lot of importance in these ones. And now we are building the RSOP files for file server. There it is, file server 10. Right. So that's all it takes to add or to onboard another computer to the DSC configuration, right? And this maybe give you an idea how easy it is to actually, do a controlled change, at least in the data. Or let's say we want to add another file to all file servers. All it requires is you go to your file server role, file server. So this is what we are doing here in the file server. Okay, let's create another directory. And the directory is called Summit. And save it. So if we kick off the build script one more time, and go to our RSOP folder. then we see there is a Summit folder, right? And it will be added to every file server that we have here because we just changed it on the row level. There it is, right? And I think this is the biggest advantage of this model to what we had before, because managing YAML files is something that is not really difficult, so you don't need to be an IT expert to add another record here to these files. And it can be handled by maybe also the first level IT department. I have just one customer who is trusting the first level IT department to change the configuration data, but thanks to the pipeline that we will see later, there is also a very effective review process that you can implement so that whatever change people do gets reviewed by an expert and tested by pester tests. Good, questions so far? So how do you guys manage infrastructure? So which tools are used in the wild to control machines? Yeah, good point. Is there something at all that is going into this kind of direction, that you have a kind of blueprint or a kind of desired state, and that some mechanism is comparing whatever is in our desired state with what we find in the open space, or is it just all done through manual processes? SCCM, okay. Yeah. With a release pipeline, versioning, and source control, or? Yeah. I know only one customer who has managed to get the whole packaged also in a source control system, but usually it's following rather old standards, yeah. Gail?
Can you show when you compare one RSOP with another RSOP, so DSC 501 and DSC 502?
Can we do the compare right here? It's been a while. Well, yeah. No, where is it? And number 2. Select compare, and then yeah. More than expected. Interesting. Yeah. Also quite nice. Yeah.
Can you manage software as well?
No. Yeah. Gail is pointing out there is a Chocolatey DSC resource, and this is all implemented in, we have 3 composite configurations that are interacting with Chocolatey resources, and yeah, that's the way to go. We have, I think, 6 customers now who are using this, mainly in the military area, so they want to deploy data centers in a very rapid way, including, I would say, everything. Yeah, SQL clusters, file clusters, Active Directory, lots of custom software, mapping software that they need. And all this is done through Chocolatey and exactly this concept that you see here. Yeah. Please.
So how do you get the DSC components that you need onto the server that can then call Chocolatey? Do you use Chocolatey in order to get DSC set up? I'm trying to figure out the chicken and the egg challenge there.
So you mean, how do you get the DSC resource for Chocolatey onto the nodes? So there is one statement, which is there is no pull without push. So this customer uses a pull server, but first you need to push the metamorph file to the node so the node knows which pull server there is. And then it can download, or it automatically downloads all the resources required to enact the configuration, right? And then they have 2 private repositories. One repository is for storing the DSC resources because they don't want to go to the PowerShell gallery. And the other one is a Chocolatey NuGet repo just for Chocolatey packages with their software. Yeah. So they have some pre-existing infrastructure just for helping making this happen. Yeah. Please.
Is it possible to achieve that portion with Ansible? You're already using Ansible in your environment for other things?
I'm not good at. So the question is it possible to kind of connect this with Ansible? I'm not good enough in Ansible to answer this question. Gail, do you have an idea?
There's no competition between the two. So Ansible can be in parallel with this.
Yeah, I tend to lose track, so I need to go back to the slides to see where I am. DSC artifacts, I think we discussed that without looking at the slides. So these 5 artifacts required for pull. And I think now comes the more interesting part, because now we need to kind of figure out how we are delivering the change, right? Creating artifacts and having these artifacts sitting on your local drive doesn't make a change. So how do we actually get the change delivered to how many computers we are configuring? And now a couple of slides that I have stolen from Gail. And yeah, one famous quote, right? Any improvement not at the constraint is an illusion. And what is the most famous constraint that we have in the IT these days? I would say it's people, right? Because you have a shortage of people, you have people that have too much work, too much technology to manage. And I still haven't read the Phoenix project. Who did? Not as many as Gail would like. Yeah. Yeah. I have a long vacation in front of me, so I will try to figure out then. But the essence here is that usually we all have a test environment. And has anybody managed to have a test environment that somehow really reflects what we have in production? Yeah, that was the answer. That was the answer. There was one German bank, I remember they had kind of a very tough outage, and then they said we need a test environment that is exactly like the production environment, and every change has to be done in the test environment first, recorded, and then done to the production environment. And it lasted, I think, for 3 or 4 weeks, or a little bit longer, and then they had an emergency. And the emergency was that critical that they couldn't even stick to the process, implemented the stuff right away in the production environment, never got back to the test environment, so their whole plan was in vain. Yeah. So I haven't seen any customer who is having a test environment that makes really much sense, and the only possibility, or the only chance to do this is having such kind of configuration management utility that does the same change in test and in production environment, right? Because if we do change, then usually it's not really, yeah, depends on the maturity of the staff, predictability and reliability. So if we do the change manually in the test environment, there is no guarantee that we will do the same change to the production environment in the same order, in the same manner. So yeah, this is kind of a problem. Let's skip the next one. Single point of failure. It's interesting, but in every IT department, you have 1 or 2 guys who know almost everything. And these are the guys that are always contacted if something goes wrong or is a bit more critical, right? And then we have the bus factor. So what happens if one or if both of these people are hit by a bus or something else happens, right? Or they're just on vacation and you need to wait until these guys are back in order to get your stuff going, right? But I think the worst problem with the old methodology is the collaboration challenge. Because there are so many changes that are never recorded or never tracked anywhere. So some financial institutions require that a change is really recorded, a screen recording, but this is not indexed. So how do you know if something goes wrong, in which recording you need to look for that certain change? It never works out, right? And the worst thing is traceability of the changes. I've just had it last week. We had to do a small change to some Active Directory component, and the customer said, well, we have a change already open. It's not really addressing that issue, but it's open, it's approved, so let's just add it to the change log, and let's do it right away. And of course, this is the worst practice, but it's everywhere like that. We have a change, getting another change approved takes too much time, so you try to squeeze it into something that is approved, and then things get a little bit bad, right? Documentation is done almost never. So there was the time when we all had to create these, the German word is Betriebshandbuch, operational manual, right? Really thick paper where every step has to be kind of documented. And then people realize that you just write the documents, but you will never touch it again. And I think these operational manuals are not any longer, are they? Do you create them? Do you still have operation manuals for? I don't think so. Yeah.
For compliance reasons.
Yeah, only for compliance reasons. Yeah, that's it. Yeah. So that's the problem, that we will never get our change in the production in the same way like we have it in the test environment. And the only way is to remove the constraint, and the constraint here is people. So if we have a process that does the change automatically in both environments, then we are fine, right? And this is the nice thing that we have here in the configuration data. Again, let me quickly show that. Here we have a layer that is called environment. We have the dev, prod, and test environment. Because, of course, there is a difference. You have different IP addresses. You have different credentials. You need to be able to reflect these differences somewhere. And for that, we have an extra layer. That means our file server in the dev environment looks slightly different than in the production environment, but still the change that we do to the server is the same, right? Good. So how can we improve this? And what I just said is having one change and squeeze as much in it as possible because it is approved is the wrong way, so we need to have small changes. And this was also a key learning. The first projects I started after getting to know the Gale project was more or less, let's do an Active Directory automation. So we need to have a domain controller deployed by DSC, sites and services configured, everything. And usually these projects have not been really successful because first we need to define the process, the pipeline, the vehicle that delivers the change. If the vehicle works, if we know that the vehicle gets from A to B always in a predictable way, then we can load more to the car, more to the vehicle, right? So small changes, especially at the beginning, make sure that whatever you want to do works on a very reliable way. And even if it works, still do small changes, because then you can trace it back and you know exactly if something goes wrong, what was the reason for that. Versioning and traceability. If somebody asks you, what is the version of a certain file server, is there something like a version at all that you attach to services and to computers? I don't think so, right? Yeah. Yeah. And with that concept, we do. So because what we are applying to a node is a MOF file. A MOF file is a set of instructions, and the MOF file contains a version. The version gets written into the registry. So we know exactly what is the version of a certain server. And from the version, we can go back to the git commit ID, so we know exactly what are the changes that have been implemented in this version, right? Yeah, visibility. Please. Whatever you want. Yeah, so we have created a demo configuration that is writing the git commit ID, the version, the date when the change has been done, but whatever you can get from the Git repository can be written into the MOF file, and the MOF file writes it into the registry. So you can have some kind of stamp on the machine. Yeah, yeah, visibility, because every change that we do through the system is in the Git repository. Okay, I didn't mention this, but of course our configuration data is in the Git repository. It's not on some file share because it's just text, and for text, Git is the ideal candidate to make things traceable, visible, and so on. And we have also a very effective way of collaboration because the Git repository is usually accessible by anybody in the organization, right? We can lock it down, but it doesn't make sense. Why not having people read the information? Who changes the data is a different story, but reading is always good. Yeah, open and accessible. And yeah, promotion, let's go to that point. Promotion of trusted changes. I think the next slide explains this a bit better than also the feedback loop. Change, trust, yeah. So this is the old process, right? In the old process, somebody does a change in a test environment first to see if this works at all, maybe in a Hyper-V machine. If this works at all, then you get the feeling of some certain trust because you know your script is working. With the script, you go to the test environment and do the same thing there. And if it works, then you add trust because now you know, okay, it's not only working in my local machine, it also works in our test environment, which has some relationship to the production environment. So let's go to the production environment. That's how it went previously. So how does this relate to promotion of trusted changes? This is exactly the same. The problem with this is that there is no guarantee that even if you have added trust, that you do the same step to the other environments, right? Maybe your coffee smelled a bit bad and you're in a bad mood and therefore you do things the other way around and yeah, something breaks. So the idea is of having a MOF file or instruction file, and this doesn't only apply to DSC. I think Chef and Puppet are working the same way. So we are creating an artifact, we are creating a package, and we are testing the package, and by testing the package locally or in whatever build system we have, we are adding trust to the package, and then we are promoting it to the next stage, which is our test environment. And by promoting an artifact, we make sure that it is not being changed at all. It's like you download Notepad++ from the internet with a certain version number. You can deploy it in a number of machines, and there is no way anybody is changing Notepad++ because you have a signed package and you have a version number, so you know exactly what happens. And so this whole process guarantees that whatever we have created on the very left side is applied in the production environment as it is, without any change, right? That's important. And yeah, this was also quite interesting for me. I like to make sure that terms are well understood and that we are all speaking about the same thing. So actually, I like the term artifact now even more because we are all some kind of artists, right? Pretty nice, yeah. Because if you write software, if you write a script, if you do anything that can be called artifacts, yeah, it's first of all, it's just something, some entity created by us with a lot of imagination, knowledge, and it is not an artifact if you don't add a version number of it. So it has to be unique. So the version number is pretty important. It has to be tested. I think it's an artifact even if you haven't tested it, but in the IT space, of course, testing it. And it cannot be called an artifact if some people are fiddling around with it on the way, right? So if you download Notepad++ and you inject some other code and somebody else is changing the version number, then we don't talk about an artifact anymore. So it's very important that wherever you use the artifact, it is exactly as it was produced in the first place. And the question is, how do we create the artifacts? And the solution is a release pipeline. What we have seen already a little bit, right? We have the build script, and the build script creates everything that we need to actually get DSC going. And another very good quote is, the pipeline applies its rules in a rigorous, unemotional way. The pipeline always works. And I was remembering yesterday evening, because yesterday evening I was testing my lab environment and wanted to make sure that a change that I have done was actually applied on the nodes. We will see later how that works. And then I thought, I don't have to test that. I don't have to look at this because I know the pipeline works, right? It's not like that you kick off a script somewhere and the script is hopefully doing the right thing because you are in the right folder. It always works. If you have proven that the pipeline works once, it works always, right? And if it doesn't work, it gives you a feedback. It tells you what hasn't worked, right? So the pipeline is the important part that is creating artifacts. Good. Sorry. And this is how a PowerShell release pipeline could look like. Who of you is developing PowerShell modules? Okay. Who is using a release pipeline to actually release the code? Oh, some of you. Okay, good, nice. Then you know how things are working, right? So our source code is in a Git repository. And if we want to do a change, first of all, we do a local clone. Then we make sure that our clone builds locally. By the way, who is using a pipeline that is also resolving the dependencies required to build the module in an automated way? Dependency resolution? Okay. What kind of tool do you use? Yeah, great. Yeah, great. Yeah, that's the tool. Yeah. Indeed, yeah. Yeah, we use it here as well, so dependency resolution, because this is quite important. Your pipeline runs finally on a build worker. You have no control on the build worker. It's pretty difficult to pre-install software, so you need to make sure that everything that the pipeline needs in order to create the artifact is downloaded during the build process, right? So if we are happy with the local change, so the build works locally, then we push it back to the repository, and then continuous integration kicks in, which means when there is a change in the repository, the build pipeline is triggered. The build pipeline is checking out our build. So it's actually doing exactly what we have done on the left side, but this now runs completely autonomous and automatically on the build system, validates the stuff and compiles the artifacts. And to make sure that the artifacts are working as expected, we are testing them, unit and integration tests, usually pester. And if this works as well, then we are ready for a pull request, right? And the pull request is then the collaboration task that informs other people that there is something that you need to review and that you need to please merge into the main branch, right? And if this happens, if somebody marks the checkbox and is happy with the change, then we are actually doing the release. And I can't even imagine anymore how I did module releases before having this implemented, right? So one of the modules that I have created a long time ago, before I knew all these practices, was Automated Lab. It consists of 9 modules. And I remember it was a nightmare to release the modules because something was not working as expected all the time. Or you didn't, or just one release didn't finish, you did it the next day, but then somebody else has changed a depending module already. So yeah, so the manual release process was really, really painful. And that's the way to go. Feedback loop will explain a little bit later. Good. And that's the infrastructure release pipeline. So the same principle is now being applied. So we have our input, our node data, our configuration data. This configuration data is somehow processed by the release pipeline, and the output is zip modules, MOV files, MetaMOV files, right? And then the only question is, how do you deploy these files or publish these files to the pull server? And this is something that most customers or all customers do slightly different, so there is no real process for that. Yeah. It's a bit more difficult than that because limit the change scope and increase trust in the artifact. If you don't use DSC on a daily basis, that might be a little bit opaque for you, but the infrastructure release pipeline needs a bunch of external resources. So if you are using in your configuration, for example, if you want to configure network stuff, then I said you need to have the networking DSC resource. The networking DSC resource is a module that is created in its own pipeline, right? So then our pipeline has to reach out to the PowerShell gallery, download the requirements first, and then use the requirements to actually produce the artifacts. We don't want to have the networking DSC resource as part of our project. So you want to have external dependencies so that whatever you change in your repository is, yeah, how can I say that? That you are limiting the scope of your repository as much as possible. Right? We only want to have the configuration data, and everything else is coming from other resources. Good. I think I told that already, but I think it's time for the feedback loop. Exactly. So if we talk about DSC, this is what we have triggered, right? Remember build script? The build script is then creating the MOV files. Everything worked fine. And the feedback loop means we need to fail fast. We need to immediately get an information if something doesn't work as expected. The worst case is that you do a mistake by your initial change in the configuration data. You propagate the change to the prod environment. Something doesn't work. You get a bunch of tickets, and you can spend the weekend solving some issues. Right? Let's create an issue, and let's see what we mean with feedback loop. So what we do is we are creating another server here. All nodes, dev, file server, file server 11. We give it the right name. Okay, and we trigger the build script. And there it is. It fails. It fails right on my local machine, telling me, wait a minute, where is it? Was it down here? Oh yeah, here it is. So there shouldn't be any duplicate IP address, but we created one, right? So if you wouldn't have catched this error up front, then you would have configured a server with a duplicate IP address, and who knows what kind of effect this has on your production environment, right? So we failed right here. And this is extremely cheap to fix because it's just our local build process. We haven't even kicked off the build pipeline yet. I mean, the build pipeline here on the automation system. We have just checked if our change makes sense and is still producing the artifacts that we expect. It produces the artifact, or it could, but our pester test has identified the problem right away, right? So the first thing that you would like to do is do a kind of integration test. Does the data that I have make sense? And the customers that I'm working with started with the default set of tests that we are delivering with the solution. And one customer has now about 900 tests because they have a pretty complex infrastructure with 70 layers, It's mind-blowing for me, yeah. And they did run into a bunch of problems. And every time they run into a problem, they make sure that they don't run into the problem the second time, right? So they write a test to make sure that whatever kind of change they do, this problem is not going to happen again, right? So the number of tests is usually something that grows over time. Yes, please.
Do you mind showing the tests that failed?
Sure. So tests, config data tests, and so let's look for IP. Here it is. So no duplicate IP address should be used. So what we do is we are getting to the configuration data, all nodes, network interfaces, IP addresses. As simple as that. And then we filter by unique IP addresses. And if the number of unique IP addresses, or we're comparing them, and if the comparing is having a delta, then we know that there was something wrong. Pretty easy. So writing the PESTA test for this, at first is a little bit, I hate writing PESTA tests for some reason. It's always more difficult than expected. But if you're on the flow, then it's only a couple of lines of code. Yeah, should be easy. Yeah. Another test that we have done after running into this problem too often, let's fix the IP address first. Let's give it the 198.8. And let's give it, for example, the location that doesn't exist. Location is where we are, Seattle. And let's start another build. Yeah, there it was something red. And it checks, is the location actually existing? So this checks, is there a file within the folder location? Where is it? Yeah. Is there a file within the folder location that has the name that this individual node has been given to, right? Yeah. It's all file-based. So it's totally, whatever you want to do, whatever you want to put into the configuration data as possible is just files. Okay, back to the pipeline. So fail fast, that means our feedback loop should immediately catch a problem. Here we did very much upfront, even before pushing the change. If you have pushed a change, then you hopefully have a bunch of PESTA tests that make sure that the configuration works. And I can't demo this in this lab, but usually this should be a test that spins up a machine, tries to actually apply the MOV file to the machine, and then verify if the MOV file could have successfully turned the machine into the desired state, right? And for this, we have, first of all, the version number in the registry, so we can make sure has not some MOV file being applied, but exactly the MOV file with the version that we expect, and is the LCM returning that everything is fine. And then I would consider this test a success, and then we can go to the next level. Let's see this in action, I think. Demo fail fast, we've done this. I've shown you if you do mistakes in the configuration data, it's catched up right away. And let's now get into, oh, there's a duplicate. I have these slides already. Let's go into a demo how delivering change actually looks like. And we start with this machine here. So this machine has an Azure DevOps environment installed. By the way, if you're interested in this kind of concept and you want to play around, then what you can do is, let's close all that. And you go into the lab folder, and there is a lab script that is deploying the environment that I'm currently playing with, either on Hyper-V or on Azure. And it installs a domain controller, it installs a SQL server, which is important for reporting, which is also a gateway. Then it installs the pull server, the DSC the DSC pull server and the Azure DevOps server, including a machine that has 4 workers to actually do the pipeline work, plus 6 nodes, the file server nodes and the web server nodes. And with this environment, you're ready to go, and you can just play with the configuration and not only create artifacts, but also apply the artifacts and see what they actually do. So if we do this, here's my project, and the other one is here. So this structure looks familiar, right? It's just the same files that you have seen already. This is the same folder hierarchy, just on Azure DevOps. And I have a local clone on the same box here. Okay, let's go to the main branch and increase the font. So let's say we want to do the same change we did previously on my local machine, and we want to give all machines of a certain role another setting. Where are we here? Roles, file server, and test Monday. Interesting, I thought I have removed it. Oh yeah, wait a minute. I need to pull the changes. Okay, yeah, I've set this to absent. So let's create another folder, and the folder is now called, today is Tuesday, isn't it? Tuesday, okay, and this is going to be present. Okay, so that's my change. Never commit to main. So what we do first is we are creating a new branch, feature branch, new, great stuff. We have a single change here. I'm not maintaining the changelog yet, and this is my change. So let's commit this, new folder. Okay, and we publish the branch. What's happening next is we can go to our Azure DevOps website. It's not COVID, I had a negative test, so. And here we go. So we have our build worker waiting for the checkout, and the build worker is going to create our MOF files. So first of all, this is the process that is creating the MOF files and packing them, and then we have three other tasks that are kind of publishing the change first to the dev environment, test environment, and then to the production environment. And then for debugging purposes, we also copy all the stuff to a share to just easily be able to access it. Okay, this takes a little bit, I think 1 or 2 minutes in order to complete. Any questions in the meantime?
So that's a feature branch, and is that going to push the test and then to prod, or do you only push the prod from your...
Only from main. Only from main. But this is something that you have to define by yourself, right? So yesterday we had a discussion with Hans. I'm not sure if we're here. And Hans said that many customers just want to buy a product like this. They just want to get it and just want to get their SQL servers or whatever installed, right? And then we tell them it's not going to work like that. It's a process. You can implement the pattern, but you need to know what you want to have, and you need to get your hands dirty and define the stuff by yourself. And same here. So the deployment process is completely whatever your organization needs, right? And I think I have not a single customer who is using exactly the same pattern like another one. So it's, yeah, depend on your infrastructure and on your processes. You see the pester test running here, same that we have seen locally. So everything is exactly the same. And what happens then is, with the publishing tasks, are actually copying the stuff to, do I have a notepad? Tools /Zoomit. This internals Zoomit. Okay. Yeah, that works. Okay, and we have the DSC pull server here. Puller1 /DSC configurations. Usually, the DSC configurations are not shared using a SMB file share. This is just for, in the lab environment, for reflecting what's going to happen. And you see all these files have been created this morning at around 7 o'clock. And we will see as soon as this task is finished, then we are going into the publishing, and we should only publish the dev environment. So we will see that after this has been finished, the file server one more file and the web server one more file should have a new timestamp. And then usually somebody needs to check that, or a pester test need to verify if these servers have been configured in the right way, which I haven't implemented in this environment. And if this goes well, then we can merge the pull request into the main branch. The main branch is automatically publishing to dev and test, and then waiting for an approval if we want to go further to prod. Yeah, almost done, packing already. Any other questions? Okay, stuff created. Deploying artifacts. I think this is even done in parallel. Yeah. So what do we have to do then? So suppose we have published our artifacts to the pull server. What's the next thing you have to do? Just
the nodes already configured to pull from the
yeah.
server? Okay. So wait.
Get a coffee and wait. Right. Yeah, that's it. So remember the constraint, Brent being the constraint because he's a very important guy and hard to catch. In this case, you just have to do the change. You have to put it into your push it to the repository. That's it. All the rest is done completely automatically. So you can actually go home and the next morning, like I said yesterday, I was checking if my my change has made it to the environment. I didn't have to check that, right? I was a little bit anxious because of the demo, but knowing that the pipeline works, your job is done, right? And here we go. We have updated the files. You can see the timestamp of these two files has changed, 10:13, perfect. I could wait now another 15 minutes because every 15 minutes, or 30 minutes, I don't remember, the nodes are checking if there is a new configuration. As we don't want to wait 30 minutes now, let's go to our file server, enter PS session. Yeah, thank you. And PS session for the DSC file 01. And what we do here is we are going to the DSC file 01 as well, DSC file 01C. Where did I create the folder? Was it in test or was it in test? Okay, yeah. Okay, and then we do an update DSC configuration, wait the both. So this is what's happening every 30 minutes. Here we go. Yes, checksum is different. Did it find a new there it is. Folder created. So, I mean, this is a very, very simple change, but we could have also installed Windows features, deploy a SQL server, whatever DSC can do could have been done here, right? And it's just, yeah, it's just you needing to make the change in the configuration data, and then it's fire and forget. So the important thing is, how well is the process defined? How well are the tests? How well is the release process? Who is reviewing the stuff? And if you have the right process in place, then you can trust it more or less. Sorry again. Good. What is our pipeline saying? Yeah, pipeline is finished. You see, it just stopped here with the dev environment. The rest is skipped. So if I'm the developer, or if I'm the system administrator, but don't have to be a developer, I have done this change in the YAML file. I'm happy with the result. So the next thing is I go to the repository tab. I go to, it's already updated, right? So it helps me selecting the right branches. I click on create pull request, edit a folder. Usually you are a little bit more verbose. Let's leave it like that here. And you click on create. Okay. Checking for merge conflicts, everything is fine. And now somebody else, my manager, my supervisor, technical responsible person needs to have a look at the pull request, can approve with questions, let's approve it, and then we can complete this. And we can also delete the feature branch because it's no longer required after the merge, and that's it. So, and if we go back to the pipeline, then we see this was built for the feature branch, therefore we are skipping test and prod. This is being built for main, so now we will deploy to all stages that we have. Yeah. That's pretty much the delivery process. So we've talked about how we can do a change, how we can express ourselves in the configuration data, which is definitely a bit more complex than, or maybe you have grasped how complex it is. It's not very easy at first. It's a steep learning curve, but if you have done it a couple of times, then things get very easy. Yeah, the delivery process, we've seen how this works. So what's missing? Reporting, monitoring. Unfortunately, we are in a kind of transition phase. We want to, a customer that is using the reporting pretty heavily has done a number of changes to the database, and it works for him but not for me. So at least we can see how it looks like, but I think the data will not be complete. So what we have is, we have a couple of tables or a couple of reports that are giving us an idea about the general infrastructure. Note additional information. So this is, for example, all the, let me zoom this in. Here we see all the nodes, in which mode they are, how the LCM is configured. So the LCM can be configured in mainly in two ways. One is apply and monitor. It means it applies the configuration, and if the configuration is not as expected, it just reports about the configuration, which is actually the mode that I would go for. The other one is apply and autocorrect. And the problem with apply and autocorrect is sometimes you have a process that changes your machines on a daily basis or a constant basis. And then the LCM comes in and changes it back. So there is a race condition and nobody knows really what's currently in place, right? So I rather go for apply and monitor so that I have the visibility of stuff that is not as I expect it to be, right? Then we have the cycles in which the LCM is working. The last update, okay. Then we have, I think the table is pretty easy. Yeah, just the IP address, the same thing. Here we see also the version of the MOF file that has been applied, plus the build date and the timestamp. The git commit ID is empty for some reason. I need to fix that, right? But this is what I told you, that you can stamp each machine and know exactly about the desired state. And finally, which is not working as expected, sorry, we have the node status overview, and this gives you an idea about, not so much, unfortunately, but usually it gives you an idea about which server is in which kind of state. In this case, fails means that we couldn't apply all the resources for a purpose, because this is the demo machine that always fails, just to show people how the report looks like. It tells you that we have 51 resources in total, 3 of them failed. It gives you the information which resources have failed, and something else. Yeah, and how long it has taken to actually apply the configuration, right? So if you want to have an idea about your infrastructure, then I think this report is giving you a first idea. And especially, this column is pretty important, that you know where to look for in case you want to get it back to the desired state, right? So, and this is only available if you are in pull mode. If you're in push mode, you have to get this information by yourself, which is not that difficult. What we can do is, we are on the file server here. So exactly the machine that is mentioned in the report as failed. So what you can do is $error for result, test DSC configuration, detailed. Then it takes a couple of seconds. Yeah, and it tells us operation will be carried against a pending configuration. So this configuration has never made it into the desired state. This is why it's called a pending configuration. Finished. And here we go. So we have a huge number of resources in the desired state, 51, as seen in the report, remember the number, and resources not in desired state, 3 of them, and here we go, right? And 3 resources failed because, let me show this. 3 resources failed because on the node level, I am adding a folder to drive Z, and drive Z doesn't exist, right? So this is the reason why at least 1 resource failed. The other resources are failing because if we go to file server, then we have a registry key, and the registry key depends on files and folders. So if we can't create all the files and folders that the configuration data tells me, then this configuration item fails as well, plus, and this one, because this one is then dependent on registry, right? So you can also create dependencies between configuration items to make sure that the flow is as expected. And we are not doing, for example, if you want to install a SQL server and you can't mount the image, then it doesn't make sense to even try the installation, right? So we are adding this kind of dependencies. And you can also create cross-node dependencies, meaning that if you, for example, install, let's talk about SQL Server again, you install a SQL Server and you want to copy the image from a file server, but the file server isn't yet ready or hasn't copied the file, then you can also do a cross-node dependency. So the SQL Server waits until the file server has done its operation, then it tries to copy the file, and then we are going to the SQL setup, right? So dependencies locally as well as between or cross-node.
I apologize if I missed
Good question. Yeah, yeah. How does it get there? So, a little bit of history. DSC was, I don't even know why they did this in the first place. The only databases that DSC supported in the first place was a EDB file, which is pretty bad because there is no tooling around it, and you can't even open the file or not even copy the file when the pull server is running. And they had support for MDB, but not the latest MDB standard. It was the 1998 MDB standard with the limit of the size of 1 gigabyte. So both was very bad choice. Yeah, and I think it was a couple of customers, including mine, that put a bit of pressure onto the product group and said, hey, we need some solution that makes sense. And so they added in 2018 SQL Server support. So that means I can't think we can even see it here. The baseline, where's the baseline? LCM baseline. So the LCM baseline defines that we are retrieving our configuration data from this server, right? And we have also a report web server. That means that the LCM is sending back a report as JSON back to the pull server. And the pull server needs to know the SQL server and the database name where to forward this information to, right? Yeah. If anybody of you wants to use this kind of stuff, pull server with SQL reporting, don't use the standard database because it lacks of almost anything. So the standard database is just 2 tables, and then you have really large JSON chunks in a SQL database, which is pretty much unmanageable to parse. So luckily, one of my customers did all the work, and the database, or the database that we have now, has a lot of triggers, and the triggers are actually kind of parsing the JSON data and putting it then in different format in the SQL database, so it's much better now. Yeah, I will. Yeah, if you're interested in this, then you may want to go to Automated Lab. Where is it? Unfortunately, it's part of another project, and it's in lab sources, post-installation activities, and then pull server setup. And here we have the scripts to set up the database. Or just trigger us on GitHub. I mean, all this stuff is publicly available, and if something doesn't work, just create an issue or start a discussion, and then we're happy to help. Yeah. The worst experience is if you go to, or if you have demoed it to somebody, the people are very happy and want to implement something, and after a couple of months you go back to the customer and then they just said, yeah, it didn't work, and then we stopped testing it. Why didn't you call me? Why didn't you open an issue, right? It's usually, thanks to all the collaboration tools that we have, that's the easiest thing we can do. Yeah. Okay, so configuration data, then the pipeline as the delivery process, then reporting to kind of close the loop. And the only stuff that we haven't, or that I'm not be able to show, is the testing on a test machine that is just spinned up for doing that particular test and then destroyed. We want to do this. We want to implement also a kind of nested hypervisor on one of the machines to have a fully automated test, but that's not ready. Maybe we use Test Kitchen. That looked quite good yesterday. Yeah. Good. Actually, here are the links, and this is the whole process. So this is what I wanted to show you. We have a little bit of time left, so we can go more into configuration data. We can discuss questions. Gail can also participate.
There's just one question. So you haven't shown a DSC configuration script. So you haven't explained why. Well, not that much.
A DSC configuration.
So you just manage data files.
Yeah.
What's the magic? You're missing just a little bit of the magic.
Yeah, I actually didn't want to go down the rabbit hole. You mean showing a composite?
Yeah, just saying why you don't need to have the script.
Good. Yeah, let's do that. It's not getting better. Okay, so let's do it on the local one. Let's do it here. So remember that we had this single slide here. Let me dig this up again, this one. And this slide tells us that the pipeline is based on a lot of different other resources. And one of the resources, of course, it's networking DSC, computer management DSC, so all the DSC resource modules, but also a module that contains composite resources. And these composite resources are actually doing the translation. And then we need to go into splatting as well a little bit, right?
No, just the common tasks.
Just the common tasks. Now we have a different one. It is this one here. Output, required modules, DSC config.demo. And here we have these configurations. So the very nice thing is, if you have put activities or configurations into composite resources, it's very, very easy to add them to a node or to a role or to whatever layer you want to add them. So for example, here we have a role or a configuration SMB shares. So let's say on our file servers we also want to create SMB shares. Then the only thing I need to do is, oops, I go back to my files. Let's do it on only one machine. And yeah, I need to talk about the configuration key then. Yeah, so one very important thing is, well, let's do it on the file server, then it's easier. File server. Here we have configurations. So these two configurations, these two composite resources are linked to the role thanks to the configuration key. So if we want to add another configuration, it's as easy as that, SMB shares. So, but just adding a configuration doesn't make a change. So let's build this. Let's do a build for filter $_node name equals DSC file 01. And then we're creating the RSOP first, and we'll realize that this configuration will be exactly the same as previously. Nothing has changed. Yeah, but we see at least it's called. So adding a configuration to the configuration key is just the call to the composite resource. But what are we missing? What's very important if we are calling into a configuration? What's usually also important if you call a function? Parameters, right. So just calling the configuration without telling the configuration what to do doesn't do anything. So the next thing is we need to understand how the parameter or how the information needs to be structured that the SMB share configuration expects from us. So edit that, and then we have another key here which is having exactly the same name, SMB shares, and now parameters. So hopefully we have some documentation. Let's see. So we open the DSC config demo and we go to doc and we go to SMB shares. Great. And here we have the usual documentation, explanation about the parameters. Hopefully we have an example. Blah, blah, blah. Yeah, and here we have examples. So what we can do is we can actually SMB shares server configure. Oh, much more has been added than I expected. So we need, so the SMB share key has another two subkeys, configuration of the server itself and then configuration of the shares. So we will take just this here. And for testing purposes, add it here. Good, so we are creating a share, blah, 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 on the temp folder, which doesn't exist. So let's switch this to test. And good. And I think these are other shares that we can remove. Okay, and building this again. All right, first we need to save it. And then let's have a look into the MOV file, into the RSOP file. Oh, where's the RSOP file? There it is. And let's go to shares. Here it is. So this has worked. So obviously, somehow, the data that we have provided has been translated, or could be read by the data module. But the next question is, could we also create a MOV file? Because this is the more important thing. Because the MOV file, or when we compile the MOV file, then actually the configuration is invoked and has to process the data. And here we go. There is our SMB share that looked good for the file server, and yeah, there is the access configuration. Perfect, that worked right away. So what's happening behind the scenes? Let's have a look at the configuration for a second. And it's in output, required modules, DSC config demo, and then DSC resource SMB share. Here we go. So yeah, here are the two parameters. OS host server configuration, and which is a hash table, and a hash table array which defines the shares. And then we have a bunch of code which is actually invoking DSC resources. As I mentioned, this is kind of a translation layer, right? We take the YAML data and we translate it into something that the DSC resource understands. And the DSC resource, for example, is this one here. Server configuration, file and folders. There, SMB share. And the SMB share resource is then invoked using a pretty helpful function, which enables splatting also for DSC, and then providing just the data that we have previously extracted. So we don't need to go into the details. But what jumps into my mind is, usually using DSC is a pretty rough start because you have to create a lot of code. With these configurations, it's extremely easy. I mean, creating the SMB share was just pointing to the configuration, providing the data in the same format that you can find in the documentation. That's it, done. Because other people have done a lot of work already that you can just pick up and use in your environment. I mean, that was one of the ideas of DSC, because previously, I think this was also something that April said in her talk, right? Every consultant has written more or less the same code and sold the same code for a bunch of customers. And none of this customer was willing to share anything because it's my code, right? So what we have here is we have a platform that is kind of addressing the general issues that every company has. Every company, regardless if it is military or finance or whatever, is trying to create an SMB share. And for the SMB share, we need to have a file and folder, and we need to have some permissions, right? So it's so easy to abstract and so generalized that why not sharing the code, right? And the DSC community has done a great work because all these modules are available in a very high quality that are doing the heavy lifting, the actual work, right? And this module here, this module is just kind of giving you the configurations that are as a translation layer for the datum concept to the DSC resources. It's all pre-created, right? This is just a demo module because the big module, it's got too big. And has taken, or the build time was too high, and therefore we try to split it up. And here you have resources for, a bit too big, yeah, for a lot of Active Directory stuff, right? So you can configure a full Active Directory just out of the box. You just need to point to the configurations, provide the data, done, right? BitLocker, certification authorities. So we have customers that are installing a full PKI system thanks to these configurations. Cluster setup. Recently we have added DNS, Exchange, Office, Online Server, SharePoint, a bunch of SharePoint resources, but unfortunately SharePoint is a beast, and the customers mentioned that almost any SharePoint configuration is so different that it doesn't make sense to abstract it here as a kind of generalized approach. But still we have the beginning here, and what I use pretty often nowadays is SQL. So installing a SQL cluster, so a 4-node SQL cluster for one customer as a demo, took me 2 hours. Because configuration is already there in the documentation. The configurations are there, so you just have to extend your configuration data, your project, your control repo, done, right? And then you have the artifacts, the MOV files containing all the instructions, and then the job is actually done by the DSC resource. So the programming effort and the programming time you need to actually get going and do even complex things in DSC is, thanks to the community work, pretty easy. Forward anything about this? Or maybe you can spend some words on the community, because this is, you're leading it.
Yeah, I'm just going to say there's the DSC community, so dsccommunity.org, and we just meet up virtually every 6 weeks. We talk about anything DSC, about the updates. We have speakers coming, whether it's about Azure, policy-based configurations, whether it's DSC, whether it's just specific to resources and things like that. And we always also on the PowerShell Discord, so aka.msps Discord, and then we're on the DSC channel. If you want to reach out to me or to anyone in the community, that's where we stay usually. You can just reach out to us. Yeah, that's the website. You can have like some information in there, otherwise you can reach out to us directly. There's a few blog posts. You haven't mentioned maintenance windows, so you wrote something for the maintenance windows.
You fixed it?
Sorry?
You fixed it?
Yeah, But the maintenance windows is something that it's not built-in, but it was something that you can implement the changes only during the maintenance windows. That was a big ask from the community using DSC, so that's implemented. It's just changing some of the data, and you can have this. And you didn't say how to get started with this for your environment. So if you want to create your new projects, how do you do?
Exercises.
Sorry?
The exercises.
Yeah, well, basically the exercise is to get started with the workshop, but it's exactly the same thing if you want to do that. You just have to copy the repository, and then you just remove the data, and create your own data, and you start it. That's all you have to do.
Yeah.
To learn, go through the exercise, and then you just take the same repository, remove the data, so then you have your notes.
Yeah. Yeah. So, as I mentioned, even the hierarchy is not written in stone, right? So I would start with a baseline, because everybody needs a baseline. Baseline, then maybe the environment hierarchy. Or let's go to the YAML file, that one here. So usually you can even get rid of this one and take your DSC LCM as a baseline. Then you have your role, then the node. So as easy as that, right? You can then remove, of course, the location folder. You can remove the environment folder. You can remove, what else do we have? The global folder, not now. And remove just all the machines in prod and test. And because we don't have an environment anymore, we can just move these machines one level higher and get rid of the dev folder. So now the configuration is much simpler. 2 machines having only one baseline, right? So we can get rid of the security baseline, we can get rid of the server baseline. Maybe you want to try building the solution before you delete too much, so you know which files you shouldn't have deleted. Let's see if it still works. We don't have a domain controller in here. We can remove. Pardon?
You have your tests. That's what
Right. Yeah. Yeah. So what are we missing now? Frankfurt. So the location is no longer there. So next thing would be just remove the location. Location Singapore, save it, and build again. Let's see if it still fails. Perfect, that's it. Right, so you can remove almost anything. We have written the tests in a way that it looks for locations, if you have some. In this case, it looks for an environment. Yeah, obviously, environment is required. Yeah, but actually, it's just a kind of scaffolding. So whatever information you want to put in there is completely up to you. I have customers that have a completely different structure, and that has not even roles, because they don't think in roles. They have some service offerings and whatever, right? So it's just downloading, getting rid of everything that you don't, or cloning, getting rid of everything that you don't need, and then trying to build. And then from this minimal setup, you're trying to add data to it, right? And what have we learned? Small changes, right? Don't do the big jump at the beginning. Don't start with a SQL cluster setup. Maybe you will succeed, but you will pretty more likely to succeed if we just control something like files and folders or registry key, right? And if this works, then let's try to add a file share to it. And if this works, then let's try to copy data to the file share. And if this also works, then we might be ready for some more advanced stuff.
So if we were to implement this in our environment, and then get everything set up and it's working and we love it, and then like 6 months later, there's some like bug fixes or improvements that you guys make in the source.
Which happens all the time, yeah.
How do we go about merging those changes? Like maybe you've added some tests or changed something.
Okay. So the question for the recording is how we can keep up with changes that the community does to resources, right? And thanks to Warren's great module, PSDepend, we have one entry point here where we define which modules to use. What I would not suggest is using latest, right? Because then you grab maybe even a pre-release that hasn't been tested very well, because up here is the allow pre-release switch. Okay, this is what we want to remove for sure. But I would just pin the version. And then you are in control of updating single modules to a newer version. And yeah, just your PESTA test should pick up anything that goes wrong, right?
So the scaffolding, there's nothing to be updated there, like you would own that as a customer, but then
Well,
depending on all
well, the scaffolding is updated as well. It's this one here. So in the talk on Thursday, 9 a.m., we're discussing more the concept behind sampler and the whole build pipeline, because this here is GitHub tasks. This is actually the build pipeline that will be updated as well, but you don't have to use it. I mean, if we have fixed some significant stuff that you might be interested in, you can, if you have pinned the version, try to download a new one, publish it to your private gallery, test it, and pretty likely it should work. Yeah.
So I think if you look at the data, the data you use, that's your data, and that's your structure specific to your business. Whatever we change doesn't affect that. That doesn't change. That's why
basically everything's abstracted, most of the stuff is abstracted into separate modules.
Yeah, nowadays. That was Gail's last work. So previously, we had the configuration data and the build scripts in one repository. Nowadays, the repository is just one single build script, just the entry point, the PSDepend file, and the PSDepend module then downloads even the DSC build pipeline as an external dependency, right? So your module is more or less only containing your configuration data, nothing else. Yeah. And that was an important change. Yeah, because many customers asked for that, because we have done some significant progress regarding the whole build system, and then updating the build system, if it's all merged into one big repository, was so painful that this was one of the most important changes, I think, in the year. Yeah.
Another question, so if I build a DSC resource myself to manage our software, so I can install or configure our software, and then I wanted to be able to use that DSC resource in this project, would I then also have to write that middle layer that sort of...
Yes.
Okay.
So the question is, do you need to write a composite resource in order to use your own DSC resource within this project? Yes, you do. But thanks to this splatting commandlet, it's usually fairly easy. Let's have a look at files and folders. So that's okay. It has gotten a bit bigger, because we are also managing now the permissions. But actually, it's only you retrieving a hash table of file definitions or folder definitions. And then you're passing the hash table to the resource. So actually the work is done in, now that's permissions, the work is done in here. No, where is it? File, permissions, content file, execution. I'm lost. Am I in the wrong one? Where's files and folders? Files and 26. No. Configuration. Yeah, but somewhere I need to, the file resource. My bad, of course. So file, there it is. So actually it's only that single line. So you call get DSC splatted resource, tell get DSC splatted resource to actually invoke the file resource, and invoke the file resource with the data that you have previously received by the hash table. That's it. So your wrappers around a DSC resource are usually 10 lines, not more. If you want to add additional logic, like here we want to create files, but also control the permissions and maybe do something more, then of course it gets a bit bigger. Yeah.
Do you have this presentation published anywhere? PowerPoint?
Not yet, but I can upload it to the same repository. So you will find it tomorrow on the DSC Workshop. Yeah. Yeah. Thanks to Git. Any other questions? Yes, please.
So you had in that example a couple of servers to deploy this to. How do you scale that to a larger number of servers?
In which way? What do you mean?
Like you had file server 1,
Yeah.
server 1, server 2.
Yeah.
Okay, you like what you got.
Yeah.
Now you're ready to actually go ahead hundreds of servers.
Yeah. 100 of YAML files. Yeah. At first, I wasn't happy with the idea of having hundreds of files or even thousands of files. Oh, sorry. Okay, last question. But the customers with a couple of thousand machines are usually having a script, and the script is extracting data from a database, creating the YAML files. And we have some customers even having an automated onboarding process. So the node is calling into the pull server through a JR endpoint. The JR endpoint is then picking up the certificate, creating a pull request. So this can be all pretty much automated. Yeah. But you have to deal with a couple of thousand files if you have a couple of thousand nodes. No way around that. But it works better than it sounds. Okay, good. Thank you very much.